What's up, scholars? Today we're talking about applications of system of linear equations in two variables. Now, when I say applications, what do you think I mean? Word problems! All right, we're going to go right into some examples. All right, example number 1. Let's take a trip to Chicago. You have two choices of transport. Option 1, the L train, which charges $10 for unlimited mileage in a day with their day pass. Option 2, Uber. You pay a base rate of $1.25 plus 95 cents per mile. Now the question is, after how many miles of traveling will it take such that option 1 and option 2 are the same price? Okay, so we're going to make an equation for each of these, option 1 and option 2, for our overall price, right? That's what we're interested in, the overall price. Okay, for option 1, it's $10 a day for unlimited mileage. So we're going to pay the same cost whether we travel 1 mile or 100 miles. Our charge is just going to be $10 per day. Okay, great. All right, so our equation for that option 1 is going to be our total cost is just going to equal $10. There's no charge per mile. No charge per mile. All right, let's write that down. From example 1, we had option 1, the L train. Our total cost, let's see, I'll call that total cost, is just going to equal $10, right? That's all we're paying. Our option 2, Uber, we're going to pay a base rate of $1.25 plus 95 cents per mile. 95 cents per mile. So you see that word per, that's going to tell us that it needs to be a coefficient in front of a variable. A coefficient in front of a variable. So we're going to pay $1.25 plus 95 cents per mile. So our equation is going to be our total cost is equal to $1.25 plus 0.95, let's say M for mile. All right, so our Uber, our total cost was equal to $1.25 plus 95 cents per mile, where M equals the number of miles. All right, the question said, when are these going to be the same? So we're looking for when the total cost is the same. We want these t's to be the same, so let's set each of these parts equal to each other and solve. When will t's be equal? That's our question. So we're saying 10 is equal to 125 plus 0.95 m. All right, now it's just a very simple algebra here. We're going to subtract 125 on both sides, and we'll get 875 is equal to 0.95 m. We'll divide by m on both sides, which are not by m, by 0.95, which I can assure you I don't know the answer to that off the top of my head. I'm just going to write that we did minus 125 divided by 0.95 divided by 0.95 should be somewhere in the neighborhood of 9-ish is my guess, because we're dividing by a little bit less than 1. Let's see what we get. 8.75 divided by 0.95, 9.2105. What should I round to? The nearest hundredth, because we're talking about the monies, which has 2 decimal points for the pennies. So 9.21 equals m. What was m? It was the number of miles. So our final answer, at 9.21 miles, at 9.21 miles, the cost will be the same. The cost will be the same. And just out of curiosity, let's see how long this would take us. Let's say we want to go from the Museum of Science and Industry in Chicago. And let's say I want to go to, let's go to the Museum of Art in Chicago. Museum of Contemporary Art. How long is this? Okay, 8.5 miles. So, if that's the only trip we're going to take in Chicago, what should we do? We should take the Uber, right? We should take the Uber, because at 9.2 miles, they're the same. We are under that, so we should take the Uber. But if we're going to take any more than this one trip, I think the L train's going to be where it's at. $10 a day, flat fee, that's going to be the best. All right, scholars, so let's look at another example. A zookeeper needs to mix feed for the prairie dogs so that the feed has the right amount of protein. Feed A has 12% protein. Feed B has 5% protein. How many pounds of each does she need to mix to get 100 pounds of feed that is 8% protein? Okay, what are we looking for? We're looking for pounds of each, feed A and feed B. So let's make that our variables. Let's say A is number of pounds of feed A and B is number of pounds for feed B. All right, so we have A is equal to number of pounds of feed A, and B is number of pounds of feed B. All right, let's go back to our question. Okay, how many pounds of each does she need to mix to get 100 pounds altogether? So when we add the pounds for feed A and the pounds for feed B, we should have a total of 100 pounds. That's going to be one of our equations. The number of pounds of feed A plus the number of pounds of feed B is going to equal 100 pounds. Got it? Okay, so our mix should be of feed A and feed B. We're going to get 100 pounds altogether. So we have the number of pounds of feed A times the percent in protein plus the number of pounds in feed B times its percent in protein should equal 100 pounds altogether times 8% protein overall. So we have the number of pounds of feed A times 12%, right? Times 12%, which is 0.12, plus the number of pounds of feed B times, I've already forgotten what it was. All right, 5% times 5%, which is 0.05, should equal the total number of pounds, 100, times the total percent, which is going to be 8%. So here's our equation. I'm going to rewrite this so the letters are in front. 0.12a plus 0.05b is equal to, we could do 100 times 0.08. That should be, move the decimal over 2, just 8. All right, so now we have our two equations. 0.12a plus 0.05b should equal 8, and a plus b is equal to 100. And now we solve. Actually, I want to back up for just a second. Why is this the way it is? Let's think about the units for both of these. This one, A is what? Is number of pounds. So A is pounds. B again is pounds. Our 100 is our total number of pounds. All right, those all line up. And our second equation, we got a percent times pounds. Percent times pounds. Percent times pounds. And this 8 came from a percent times a pounds, right? Our 100 was our total number of pounds. So this is also percent times pounds. That's why we had to make sure we were multiplying by that 100 total pounds. Okay, now let's go ahead and solve this. What would I like to do? We could use like any method. Any method is totally fine. Let's do, because I don't use it very often. Oops, sorry about that. Let's do some substitution this time. Let's do substitution. Let's write this equation as an equation in terms of b. So let's subtract a on both sides, and get b is equal to 100 minus a. Okay, and then we'll plug that in this first equation. Let's let my paper up. Great. So I'll have 0.12a plus 0.05b is now 100 minus a is equal to 8. I need to multiply through. So 0.12a plus 0.05 times 100, I can do that. That's going to be 5 minus 0.05a. 0.05a should equal 8. Combine these two together. 0.12 minus 0.05 is going to be 0.07. 0.07a, just combine my like terms, and then I'm going to subtract 5 on both sides. Minus 5, that's 5. Looks like my orange marker needs to go. Bye-bye. So that'll equal 3. And then divide by 0.07 on both sides to get a equals 3 divided by 0.07. Whoops, nope. 3 divided by 0.07. 42.857. Let's round to the nearest hundredth, because that's what we've been using as our largest amount of digits here. 42.86. And what did A stand for again? Number of pounds. A is number of pounds of feed. So we've got lubs. And then we can plug that back into, let's use this equation. Sounds great, to solve for B. So we'll have, instead of A plus B equals 100, we'll have 42.86. Yep, plus B is equal to 100. Subtract 42.86 on both sides. And get, I don't feel like doing it in my head, so I'm not going to. Alright, sorry, my video cut me off there. I just plugged it in my calculator and got 57.14 pounds of the feed B. So those are our two amounts we need for the two different types of feed so that we can get 100 pounds overall of an 8% mixture. Alright, we're going to do one more example. Last one. In triangle ABC, the measure of angle A is twice the sum of the measures angle B and C. The measure of angle B is 3 times the measure of angle C. What are the measures of the angles? Alright, let me read that again. Sometimes the first reading is just words, and then I read for understanding. Okay, in the triangle, the measure of angle A is twice the sum of the measures of B and C. So it looks like we're going to have A, B, and C as our variables, the measures of A, B, and C. So A is equal to twice the sum, 2 times what we get when we add B and C. So let's write that down. All right. A is equal to twice the sum of B plus C. Got it? The measure of angle B is 3 times the measure of angle C. All right, so B is going to equal 3 times C. A should equal 3 times C. Now in this case, we have 3 variables. That means we need 3 equations to solve this. What else do we know about the measures of angles and triangles? They all add up to how much? 180! The measure of angle A plus the measure of angle B is going to, oh, nope, plus. I need 2 pluses. That should be a plus. The measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. All right, cool. So now we get on to the business of solving. Okay, so let's use some substitution on this one. In this third equation, let's plug in for what b is, 3c, into here. And let's also plug that into our second equation. So in our second equation, we'll now have a is equal to 2 times 3c plus c. And we've got, actually, let's just stick with this for a second. Okay, so let's multiply this through. We'll have a is equal to 3c plus c is 4c. And 4c, sorry, my video keeps cutting me off. All I did was say 4c times 2 is 8c. Now we're going to plug this into this for value for a. So we'll have 8c plus 3c plus c is equal to 180. Now we can solve this for c. Great. 8 plus 3 plus 1 is like 8 plus 4 is going to be 12c is equal to 180. So we'll divide by 12 on both sides and get 15. So angle C is 15 degrees. I can plug that in here for B. So B is going to equal 3 times 15. 3 times 15 is 45. And then you can, I kind of want to plug it back into this equation. It's kind of what I'm feeling right now to solve for A. So A plus 45 plus 15 should equal 180. A plus, that's 60, equals 180. Subtract 60 on both sides, and we'll get A equals, that's a 6, definitely, 120. Okay, so we've got our three angles, A, B, C. A is 120, B is 45, C is 15 degrees. That all came from our original equations. We were given two of them. We had to access some prior geometry knowledge to know that all three angles in a triangle add up to 180. All right, scholars, let's do a brief recap. What did we talk about? Talked about solving systems. While you were going through these notes, I hope you wrote down the questions. That would make a lot more sense. If you didn't, go back through and write down the questions that went with these things. For applications of systems, all word problems, of course. So we did the one with the L train versus the Uber, where our total cost for the L train was going to be $10 a day regardless. The Uber was going to be $1.25 plus 95 cents per mile. We were looking for when the total cost is going to be the same. So we set their expressions equal to each other and solved. Then we did the mixing problem, identified our variables. A was number of pounds of feed A, B was number of pounds of feed B. The total number of pounds needed added up to 100, and we made sure in our second equation, where we're using the percentages, that our units lined up. It was percent times pounds, so that's why we needed to multiply by that 100 for that percent times pounds. And finally, our triangle activity, which was delightful. I'm sure you'll agree. All right, love you so much, scholars. Keep on that hustle. I'll see you next time.